Alright, draft physics video. I figured I'll do one of these Theoria videos. First time ever seen geometry of space force and counter space inertia. And it's another one of his really poor experiments. I mean, just so bad. So he takes a bottle that's round, that's shaped, and presses it on a magnet with ferrofluid in it. And obviously the round bottle, when you compress it, it doesn't go flat. It's hard plastic, and so it bulges the opposite direction. The extra plastic can't be made flat, so it pokes in the other way and creates a donut shape. And he thinks it has something to do with the magnetism. Or he's selling the idea that it has something to do with the magnetism. It's hard for me to imagine he could be dumb enough not to see what's happening. And it has nothing to do with magnetism. Magnetism leaves in straight line force. It's like magnets radiate magnetism like a light bulb. And I would argue the difference is it's red light at one end and blue light coming out of the other end. But it's a straight line force. That's Maxwell's equations. And the only thing that ends up having a shape is the strength of the dominance of one of those colors. You can sort of understand that if you had a red light bulb and you had a blue light bulb upside down, that their radiation would mix, okay, at points. And so you wouldn't have red or blue, you'd have a mixture of violet. And that the violet range wouldn't be as strong. And the blue would be very strong to the red, and the red would be very strong to blue, to another magnet, but the mixed color would be the weaker magnetism. And that's how the field lines line up, is sort of on the strength of the magnetism. And the fact that it comes out looking a little donutty, or hyperborealoidy, or hourglassy on the inside, or however you want to diagram that shape is just a consequence of the field strength, the dominance of one of those colors. The more dominant, the stronger. The less dominant, then the flatter, weaker it becomes. So anyway, this is so poor. Well, anyway, 195 likes, 9 dislikes, and it's just a piece of crap as a scientific experiment. So I'll just run through some of it. And it's it's a 10-minute video where he says nothing. Literally
this will
nothing.
Be fun. Here I have a Palm Wonderful empty container. Now the one thing that's neat about these spherical shapes is they obviously act like magnifying glasses when you look at them from the other side. So inside is
very poor magnifying glasses, by the way.
Just regular tap water. And I have some special ferrofluid in here. You'll notice it doesn't look like regular ferrofluid. It looks brown and sludgy, kind of like molten chocolate. You see those two spots right there? I'll make mention of those in a minute.
Yeah, I don't think he will, but anyway, let's keep going. He doesn't do it in this part anyway.
The magnet.
So he's just showing us the little magnet. So the white spots are where the magnetism is mixing. So that's why the line in between is so bright. It's because that's where the magnetism is technically kind of, I don't know if weak's the right word, but it's mixed. The red and blue are exposed to each other.
See that? Okay, now we're looking at this.
So it flashes it kind of quickly, which is sort of annoying. Alright, so now he's doing so he's pressing the bottle.
Oh, poo. It kind of looks like that. There's just a little air bubble in the top, no big deal there. You notice if I actually press in a little bit, you'll actually see the geometry of the magnet.
No, you'll see the geometry of the bottle. I mean, it's just so bad.
As long as I get it right there. There we go. So the lens looks perfect.
So as the roundness is being pushed here and here, it means the bottle is popping back up this way. So that's why the fluid is flowing down, is because there's actually a little hill of plastic here and here. So it has absolutely nothing to do with magnetism. It just has to do with the fact that he's compressed a round surface and it's reflecting back.
There you go. Now you can see the hourglass shape better. Do you see that?
See, so he thinks this has something to do with magnetism. Like, this is what it would do if you put it in a square box and set it on there. It wouldn't do this. It's just a complete distortion. It's of no value at all.
And what are we looking at right now? We're looking at a hyperboloid. What's the inverse image of a hyperboloid? That'd be the torus or the toroid.
The toroid, so that would be the donut going around here. So this is the donut, and this is the hourglass inside. But again, it has absolutely nothing to do with magnetism.
Right now we're looking at the negative.
You could do this with gravity by just putting oil in water and compressing the bottle, and you wouldn't even need a magnet. You could make the same shape without the magnet.
The image.
I mean, this is how he could do his experiments, you know, and he doesn't do them this way. He could just do this on the table and then show how, we'll see, when I do it on the table, this doesn't happen. But it will happen.
Of the torus, we're looking at the hyperboloid. We're looking at the cross-section of the magnet along the plane of inertia. Right? Have high magnetic flux right here.
High magnetic flux. So that means it's radiating more magnetism of the right color, specific colors, red and blue.
Low at the center. At the center of any magnet.
Yes, well, the center line, it's really not the center of the magnet. So he keeps saying center of the magnet. It's not the center of the magnet. It's an entire parallel plane through the entire magnet that divides the blue light from the red light. It's where the filter changes. Sheesh. Anyway, so let's do some more of this pressing of the bottle. Okay, so now he's made his donut, his toroidal. He's toroiding by pressing a round bottle. So you see the roundness. When you push it, it doesn't go flat. It pops back the other way because it's hard plastic. It's not soft plastic. It's rigid plastic.
You see the torus we're looking at right here? We're looking at a donut, aren't we? Actually, you're able to point the camera in a little.
Right, a completely contrived and made up thing that has absolutely nothing to do with magnetism. Around this rounded edge here is created by the roundness of the bottle. So this is completely circumstantially, of course it's going to be round. It's a round bottle. The goop is going to go round because it's a round bottle and you're forcing it to pop up in the center. And yes, the goop won't climb the mountain because it's magnet. It wants to go where the magnet is. It doesn't go up. It goes flat as it can get.
But more over top of this, you'd actually see the full donut on this side. This is a wonderful little container, which had pomegranate juice in it. Here we go. Let's use the smaller.
I mean, when he spins it, you can actually see some of the interesting things of the field lines, and you can see that it takes time for those field lines to dampen. You know, the magnetic effect isn't instantaneous.
For this, just ignore the air bubble in the top. This is a smaller sphere.
Yes, doesn't create as good a round because it's a tighter oval, so it obviously pops it in a straighter line. So just so obviously nothing. This is so obviously a nothing experiment. Jump ahead a little further.
So why is there no ferrofluid in the center here?
Because you're pushing the plastic in, because it's rigid plastic and it can't go flat. If it could go flat, it'd be flat here right now. There's extra rigid plastic, and when you compress it, it has to dimple in. That's why. Obvious. This one isn't even a challenge. This wouldn't challenge a class of third graders could figure that out.
The closer I'm able to get it, the more the hole expands. The more it defines a donut.
Yeah, so now he's saying the closer I get it to the magnet, you know, it's a thin layer of plastic. It's always the same layer of plastic. There's just how much plastic you're pushing back up.
Oh,
amazing.
All forms of donut. All I have to do is actually change the viscosity of my ferrofluid in this tap water solution to actually show the geometry of dielectricity.
So this has something to do with dielectricity. Yeah, oh sure it does. Alright, so we'll move to the hourglass again.
This is the geometry of counter space.
Yes, so it has
Is that
this
pretty simple?
counter space. As opposed to space, it is the counter to the space. The space is something, the counter space is nothing, I think. Something like that. I would think it would be the other way around, but, you know, what do I know? I'm not a silly guy who speaks Greek. Yeah.
Was that pretty simple?
It was pretty
By the way,
retarded.
no one's actually seen this before because ferrofluid normally does.
Nobody's ever seen this before. Another one of his bold statements.
Doesn't act this way because it has incredibly high viscosity. This is a very low viscosity ferrofluid.
Yeah, well, they make clay. I have some, actually. Ferro clay. So this is not brandy newy.
So, geometry of counter space, dielectricity.
Geometry of compressing a round bottle, and it creates bulges right where you compress it. Wow, what a surprise.
Perfect hourglass shape, isn't it? Actually, it would be a perfect hourglass shape if this magnet were larger and shaped like a cube, but it's not. It's rectangular, so that's why it is not a perfect hourglass.
Yeah, that's, you know, when you put it on the flat, round surface, it compresses the bottle in a different location when you put it on the rectangle surface. Yes, correct. It reflects it. It pushes the plastic in on the two sides. When it's the narrow surface, when it's the wide surface, it compresses the center. Ooh. Like I said, third graders could dissect this.
Maybe you could take a guess at it.
Alright, so here we go.
If I drop the ferrofluid, watch how it falls when I actually take the magnet. Now we're using one pole with the magnet. When I let go of this and let it drop to the bottom, watch how it falls. Actually, I have to bring it up.
Yeah. Well, that's because it's sticking. It's clinging to the surface because it's oil and water. It doesn't mix with the water. So when you push it all the way up, it basically has a whole surface of water underneath it, and so it clings to the plastic rather than go into the water. It's called surface tension. Third graders might know something about that too.
Okay, let's watch again. Let me get a view of the camera. 1, 2, 3. And if I actually bring it over along the plane of inertia, it'll always form a cup shape. The unfortunate thing is they have the camera directly over top of it, so I can't lift it straight up really fast without hitting the front element of the camera lens. But see that?
Yeah, it's just the shape it starts with is the shape it ends up going with. So the more spread out it is, it's going to move differently than the more confined it is. Obviously, when you're using only the smaller side of the magnet, the fluid's going to be more condensed than when you have the broader side of the magnet. So move ahead a little.
A hyperboloid. Field pressure mediation. You see, the universe and Mother Nature are really goddamn simple.
Yeah, well anyway, this is 4 simple tons. This is junk, pseudo, crap science. You really shouldn't make videos like this. It's hard to take you at all seriously if you're going to sit there and play a game like this and say this has something to do with the geometry of the force of the magnet when it has entirely to do with the geometry of the bottle you have the fluid in.
Everything works off pressure mediation. What's pressure mediation mean? No difference saying pressure mediation than saying water flows.
Well, obviously everything works on pressure mediation in the sense that if you want to say interactions are pressure, then yeah, you know, the more people that are in your apartment, the more crowded it is, the more you feel the pressure mediation need.
Downhill, yeah. You see this? What are we looking at now? We're looking at the cross section of an hourglass, a hyperboloid. Now.
So he does the same thing over and over again. Like I said, that's his typical style. He's got to repeat and repeat and repeat and repeat and repeat, and he doesn't rinse anywhere in here.
The cross section of a donut.
Yeah, of a bent plastic pushing back up.
A torus, right? Donut / torus versus the geometry of counter space. Listen closely. This is the end of this video. I want you to pay attention. This is the geometry of counter space. This is the geometry of
So that was counter space, was the hourglass, and donut is, wait for it,
space.
Space. So donuts are space, and hourglasses are counter space. Ah.
This is force and motion. This is space. This is inertia and acceleration. This is counter space. Yeah, girlfriend.
So I have to remember this. Hourglasses are counter space. Donuts are space. Didn't you just say the opposite a minute ago?
You saw it. So, this is the world's first video. Simplicity is divinity. Man, oh man, it doesn't get any simpler.
So again, first time ever seen. I mean, you know, why don't you get a set of Tinker Toys and do a first time ever seen video?
Than this, other than my special mix of ferrofluid here. This is a pomegranate juice bottle. And tap water. Yeah.
Yeah, well, ferrofluid in liquid solutions, they, you know, sell that on eBay. It's a kid's toy.
That's right, girlfriend. Thank you so much for watching. This is a world's first. No one's ever shown you this before. If you like this video, you could drop a...
Yes, no, gee, nobody showed us the fake plastic bottle trick. Yes, that's right, because most people have more integrity to throw something that fake and phony into their science videos, where they claim to be authorized who can insult all the great dead scientists of history. Yeah. So Einstein was an idiot, and you're not a fake. Sure. Anyway, so I just post this. I'll post it on the message board. You know, there's somebody put a whole bunch of these different scientists as a list, and so I'll just post it as a response to the Theoria thread. Yeah, the phony, the faker should find that and actually, you know, I have some questions I have to answer. Gerard. Anyway, so what am I going to look? How do I find? I'll just go to the website. Yeah, that's how I'll do it. I'll go to the website. And it's missing. Where the hell did it go? I didn't think you could look at just the... Well, I guess you can. Alright, the physics forum. And then we go to... bullshitters, I think they're called. Crap science for dumbasses fall for. Yeah, that's it. And there he is, Theoria. So I will post it as a reply. I already posted one reply, so I guess I'll just post it as a second reply. Yeah, I might as well make it an official reply. Okay, anyway. So, yeah, enough of a video. There's so much about conventional science that needs to be challenged, but it needs to be challenged with people who are, you know, honest. You know, not dishonest.